Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is the lecture on IR spectra, lecture number 7. In this lecture, I will explain you different types of vibrations in molecule. Okay. Normally, when molecule absorbs infrared radiations, vibrations and rotations of atoms within molecule appear. Here, for infrared spectra, mainly vibrations are more important, and there are two types of vibrations. First one, stretching, and second, bending or deformation. So first of all, let us take stretching. In this type of vibrations, the atoms move essentially along the bond axis, so that the bond length changes at regular intervals, but the atoms remain on the same bond axis. There are two types of stretching. First one is symmetrical stretching, and second is asymmetrical stretching. So let us see stretching vibrations in polyatomic molecule. So first of all, we will see symmetrical stretching. There are two types of molecules, and therefore we will see symmetrical stretching in both types. The first one is linear molecule. So in linear molecule, what happened? Let us see this one. Here we assume ball and spring model for molecule. So these are atoms of a linear molecule, and the spring is bond. Here, this is central atom and these two atoms are at equal distance from the central atom. Now, when these two atoms stretch symmetrically, that means these two end atoms will go away from each other from the central atom, and in that case, these atoms move quite far from the central atom with increasing bond length like this. Okay, so here there will be increase in bond length. Second type of symmetrical stretching is possible within molecule. Here we are keeping all these atoms at equal distance from others. Now these two end atoms move towards central atom, both in the same direction, in opposite direction from each other. So that what happens, the end result will be central atom is as it is, but these two end atoms are coming close to each other, and therefore here there will be decrease in bond length. So here you find change in bond length. Okay, so this is called symmetrical stretching in linear molecule. If in any case dipole moment changes, then this mode of vibrations is IR active. Otherwise, this can be IR inactive. In case of non-linear molecule, let us see this one. In case of non-linear molecule, we'll take this example. This is ball and spring model. Here this is non-linear molecule. Now if this molecule where end atoms move away from central atom, again there will be increase in bond length without changing bond angle. Then central atom remain there only, but these atoms and atoms will go away from central atom like this, and here bond length changes, rather increasing. Okay, so there will be change in bond length. That's it. Second, here if these two end atoms are coming towards central atom, then there will be decrease in bond length only, so that central atoms remain there only, but end atoms are coming closer like this. So here bond length will be decreasing. So in both the cases, both the molecules, bond length changes without changing bond angle, and this is called symmetrical stretching. Okay, this will be symmetrical stretching in non-linear molecule. Now we'll see asymmetrical stretching. Second is asymmetrical stretching. Asymmetrical stretching. First of all, in linear molecule, here all atoms on one line at the same distance from others. Now here one atom will be going in this direction, another is going in the same direction but away from central atom. So if this bond length is R0 and this is R1, now see what happened when atoms move in this molecule. This is central atom as it is, wherever it is, and this right side molecule is going away from it and left side is coming close to central atom. Okay, so we get a new distances. This is called R0 dash and this is known as R1 dash, and these two are different from the original one. And here bond length changes. Bond length changes in both the cases. And it is clearly visible that R0 is greater than R0 dash while R1 is less than R1 dash. Okay. Now see what happened in non-linear molecule. In non-linear molecule, what happened when asymmetric stretching takes place? So here atoms are at definite distance. Now here also one atom will go in this direction, another will move in opposite direction. Okay, so these are the distances R0 and R1, both are same in fact. Okay, and here when bond length changes, what happens? See this. One central atom as it is, this left side atom is coming closer and right side is going away from this. So we will find a change in bond length in both the cases. Now we have a new bond length R0 dash and R1 dash over here, and in both the cases you will find change in bond length. Changes. Okay, here also R0 will be greater than R0 dash and R1 will be less than R1 dash. Okay, so this is called asymmetrical stretching. Okay, in this kind of stretching, one atom moves away from the central atom while the other atom moves towards the central atom. As bond length changes in both type of molecules, there will be change in dipole moment also. So there will be definitely change in dipole moment, and I think that's why all asymmetrical stretchings are IR active. Okay, because there will be change in bond length, so there will be change in dipole moment, and therefore both asymmetrical stretchings are IR active. Okay, so this is all about stretching in this lecture. Thank you so much.